Section 2.3, and I put A because we'll take this into a couple different sections. I can't remember, maybe 3. Can't remember what it is. It's either 2 or 3. We're going to talk about a thing called imaginary numbers. So let's write that down. Imaginary numbers. So that's the first thing we're going to talk about. And then I think in the next section of this, let me see. No, I do it in this section. We're going to talk about, now imaginary numbers is one thing, but a combination of imaginary numbers and real numbers are called complex numbers. So here are a couple words that we're going to talk about today. Just thought I'd just throw them out there at first, and then we'll talk about what each of these are. I actually had a class in college called complex analysis. Doesn't that sound awful? It pretty much was. The course wasn't so bad. The teacher, I won't say the teacher's name because who knows who could be watching or listening. Probably not too many by the looks of my views on the YouTube, but anyway. He just made me just hate complex numbers just because of who he was. He was I tell you that story about him ripping the girl's test up and then making her cry. Did I ever tell you that? Probably told it last year, wasn't it?
No.
Was it this year? Yeah, that's the guy who taught that class, complex analysis. So, but anyway, I've gotten over that, and I'm fine with complex numbers now because they're actually pretty easy. People look at this and think, imaginary numbers, what in the world? Again, it's unfortunate. I said this earlier before we started recording. It's kind of unfortunate that they call them imaginary numbers because people think they don't really exist. Well, they do exist, but they don't exist on the number line like we're used to, right? We're used to seeing a number line, with positive numbers, negative numbers, and all that. Tiffany mentioned pi and e. Well, pi is still a real number. It's just an irrational number. You can still, yeah, I'll just say it that way, that pi is still a real number. But we really haven't talked about imaginary numbers. Well, let's do this. Who's got a calculator? Anybody got a calculator? Tori, you got a calculator. Anybody else got a calculator? Have a couple people do this. What I want you to do is I want you to put this into a calculator. The square root of, let's say, negative 25. Put that into a calculator and tell me what your calculator tells you. Don't cheat.
I'm not cheating. I know. Calculator.
I know. What'd you get? Error. You got an error, didn't you? No, why? Did you just make a mistake? You just don't know how to put stuff in a calculator, right? Is that what it is? Yeah. What did you get, Leslie? Error. So you can't use a calculator either, right? What'd you get? Boy, nobody can use their calculators. What's going on? No, it has nothing to do with that. It is an error because it can't exist. Let's go back to Algebra 1 a little bit, or even pre-algebra, and learn the rules for multiplication. Do you remember that? So if I took a positive, put a dot, times a positive, what are you going to get when you multiply two positives together?
Positive.
You get a positive, okay? And the rule, and let's do this. What if you had a negative times a negative?
Negative.
Is it? Negative times negative?
Right. Positive.
It's also positive. Okay, so when I teach this rule, I say when you multiply two numbers together, if they're the same sign, if you multiply two numbers together, they're the same sign, you'll always get a positive answer. So what do you think if I multiply a positive times a negative? What are you going to get? You're going to get negative. And the other way around too, right? If I go negative times positive, same thing. So if they're different signs, your answer is always going to be negative. Agreed? Now, let's think about the square root. What does the square root mean? For instance, let's just go 25 right now. Now, we know what that is, don't we? What's the square root of 25? It's just plain old 5. Now, what are we asking ourselves when we're doing the square root? We're saying what number, times itself. Good. What number times itself? So they have to be the exact same two numbers, right? What number times itself is equal to this right here? That's what the square root is telling you. So, well, 5 times 5, right? 5 times itself is equal to 25. Is that the only thing that multiplies the only same two numbers that become 25?
Negative 5 and negative 5?
Right. Negative 5 times negative 5 works as well, doesn't it? Did you ever think about it that way? Okay, because we always say just 5, don't we? If I said what's the square root of 25, almost everybody in here, probably without exception, would just say 5. The square root of 25 is 5. But guess what else? The square root of 25 is also what? Negative 5. Why? Because negative 5 times itself is equal to positive 25. Would you agree? Well, with that in mind, okay, with those rules in mind, let's go back to that square root of negative 25. Now remember, the square root means the number times itself. They have to be the same exact two numbers. Can I get the same exact two numbers to multiply together to become a negative 25? Or really, a negative anything. Would you agree?
I.
So you can't. So you cannot take two numbers, two of the same numbers, multiply them together, and get a negative anything. Why? Because the rules of multiplication say, if you're going to multiply two numbers together and get a negative answer, one has to be negative and one has to be positive. That automatically means those numbers cannot be the same numbers. Would you agree? -5, +5. That's -25, but are they the same number? Obviously not. -5 is not the same number as +5. Agreed? So do you understand why it gives you an error here? Okay, because there are no numbers. I could put negative anything inside of a square root. I could put -3. I'm still going to get an error because there's no way that I can multiply two numbers to get two of the same numbers together and get negative anything. All right? So what do we do? Okay, where does this imaginary number come in? Well, it comes in right here. What we do is, this is a definition. All right, this is a definition of basically the letter I. We're going to use the letter I probably because it's imaginary, I would think. I never did any research on it. I just kind of assumed that they use I for imaginary number. All right, so we're going to talk about the definition of I. And here it is. Watch. If I take the square root of -1, now remember, that doesn't work. If you try to put the square root of -1 in your calculator, I cannot take a number times itself and equal -1, can I? Can't do it. All right, so what do I do then? They say, okay, we can't do this on the real number line. It doesn't exist as we know it. Or even our calculator says it doesn't exist. Our calculator says we get an error if we try to do this. So what they did is they said, whoever they are, I don't know who came up with this. I think this guy named Euler, and actually you don't spell it E-U-L-E-R. Okay, it's pronounced Euler, not Euler. It looks like Euler, doesn't it? But he pronounces it Euler. I don't know. I've looked this guy up before. I've talked about him, but I can't remember much about him. But you can look it up. You got the internet. You got the whole information, all the information in the world at your fingertips, okay? So you could look him up, I guess. But he came up with this notation anyway. They probably knew of this whole theory beforehand. I don't think Euler's the one that really came up with this, but he was given the notation. And they give it his name, Euler notation. So what we do is we say the letter I is equal to the square root of -1. This way, we can actually do some work with it. We can do some calculations with it. And you think imaginary numbers, if they're imaginary, they don't exist, why would we even want to use them? And I had that question for a long time. Even when I was in college, I told you I took that class called complex analysis. I don't think, if I remember, I mean, this was like over 25 years ago, so I don't exactly remember, but I don't think he ever told us like why it was useful. Okay, we never did any practical, and we're not going to do that in here either. If I didn't do it in college on a class all about these numbers, we're not going to do it in here. But through my years of teaching, I taught this kid, pretty bright kid, you know, really energetic and a go-getter, and he eventually became an engineer at Boeing, and now he actually quit his Boeing job, which was a pretty lucrative job. He worked on helicopters over at Boeing near Philadelphia, and he started his own computer business, and now he does that full time, and he's doing real well in his computer business. Well, you know, he was one of these. He won't mind me saying this if you ever heard this, but he was kind of one of these geeky kids, but in a good way. You know, he was really bright and stuff. But he was working at Boeing at the time, and I saw him at church. I was like, Danny, you know, I'm teaching this I stuff, this imaginary number and complex number stuff. I said, do you guys use this at all? He says, oh, let me tell you. He says, we use this all the time. And it was like in between Sunday school and church, and we're sitting there in the lobby just talking about this, right, in church, you know. So I guess I'm a geek too, you know, when it comes to this. So, and he was telling me, oh, yeah, this is how we use it, and we do use this, we do all this stuff. And then he says, we got a few minutes. Let's go up to your room, because my classroom was at Newcastle. We were in the same church building and stuff. So went up to my room, and he's on the board. I mean, he fills up the whole entire whiteboard with all these things that you use imaginary numbers with. I mean, it was like crazy, and it was way, way above my head, stuff that I had no idea. I'd just sit there and nod at him, you know, okay, kind of like what you guys do sometimes when you have no clue what I'm saying, right? I know it, because I've been there. I do the same thing. I'm nodding, okay, yeah, well, I'm thinking, dude, I don't have a clue what you're talking about. But he showed me, he took a whole, we actually missed the church service. We stood in my room the whole entire church service so he could show me how people use imaginary numbers and complex numbers. Now, do I remember any of that? That was like 20 years ago when that happened. No, I don't remember a whole lot of it, but I know it had a lot to do with electricity and things like this. But he said people actually use it all the time, every day. All right, so just take my word for it. Is that all right? I don't think you really care to go through the exact, reasons why we would use this, but it is used. People out there use it. Now, will you use it in your everyday life? Of course not, okay? Not everything you learn you're going to use in your everyday life, but that doesn't mean it's not worth learning, all right? So we try to learn things just for the sake of learning. I tell you, that makes life a lot easier for you, especially in school, when you just get that idea that, hey, look, it's just good to learn stuff because God put stuff out there. He made this universe. He came up with this imaginary stuff. I mean, it's just people discovered it, okay? But God put it out there. It exists in nature, and it's good for us to learn stuff, even though we might not use it every day. So, are you going to use this? No. You're going to go to the grocery store and have to use imaginary numbers and complex numbers? Of course not. Have I ever used it in my life except for teaching it in class? No, not at all. All right, but it doesn't mean that it's not worthwhile to learn, all right? Because there are people out there that do use this stuff. So let's do this. So what did we say? We said the square root of -1 is equal to I, correct? So what we're going to do, let's make this a little thicker. What we're going to do, let's take that square root of -25 again. And what we're going to do is we're going to simplify this. And they're going to say, now this problem right here, it says write without negative radicands. A radican is the thing that's inside the radical. So it says write this without a negative inside the radical. All right, that's basically a fancy way of saying it. Does that make sense? So we don't want the negative inside of here because if I put that into a calculator, I'm going to get an error. So what we're going to do is we're going to break this down. Keep it under a square root. Now watch what we can do. Remember, this is very helpful. Right there. That's extremely helpful. That we know that the square root of -1 is equal to I. Well, we can take this -25 and break it down into this. Watch. 25. Well, let's do this. Times -1. Would you agree that that's true? 25. I guess I don't really need that dot right there, do I? 25 times -1 is equal to -25. Would you agree we're okay so far? All right. But look what I did. I multiplied it by a -1 here because look at this thing right here. I know what the square root of -1 is. What is the square root of -1? It's just the letter I. It's not a variable. Okay, it's not like an X or a Y. We're trying to solve for I. I is defined to be a certain number. Okay, like pi. Pi is not just any number at all, is it? What's pi? It's exactly, well, it's not exactly because it keeps on going. But anyway, pi is what? 3.14, right? So it's not a variable, is it? So I is not a variable. It actually stands for a certain number. So what we're going to do is this. Break this down. Remember the rule that says if things are being multiplied together inside a square root, I can go to the square root of 25, and I can go to the square root of -1. Do you remember that rule? We did that earlier in the year, didn't we? To go from there to there. Everybody okay? I'm not just doing a little magic, a little mumbo-jumbo here. I'm not at all, okay? I'm following rules. Now, look what we did. What is the square root of 25? Just plain old 5, isn't it? Now, what is the square root of -1? It's an I, so we're going to put an I. It's not the square root of I, is it? It's just the letter I. Again, it's not a variable. It actually stands for a number. So what are we going to do? We're going to take the square root of -25, and we're going to write it 5I. That's something that you can't do in a calculator, okay? Your calculators aren't doing this for you. You have to know the rules, but it's pretty simple. And we can do stuff with this now, all right? We'll talk about the complex numbers here in a second. Let's do a couple more of these. Along the same line. We'll make this pretty easy. Then we'll make it just a little bit tougher, not much. Eventually, see all these steps that we did right here? What I want you to do very, very soon, all right? Not take weeks to learn this, but very, very soon, hopefully by the end of this class, that you should be able to go from this to this completely in your head. You think you can do that? Because look at it. Whenever you see, let's look at it this way. Whenever you see a negative inside of a square root, what does it really become? becomes an I. That's right. So anytime you see a negative inside a square root, it just becomes an I. Now remember, it's not under a square root though, is it? It's just sitting out there. So a negative inside a square root becomes an I. You get it? Outside the square root. It's not inside the square root anymore. Okay? And I'll show you an example where you could get confused. So we put it out front like this. Now, some books will write it like this. They'll put the I first and then the 5. If this just is a nice whole number like this, I probably would prefer that you write it like this. Put 5I. It makes a little more sense. But sometimes you might see it written like this. Okay, I5. If you look in the book, or if you look in the answer key in the book for the odd answers, you might see the I out in front. Let's do this one. Let's see if we can do this in our head. So look at it. First of all, we got a negative inside the square root, don't we? So what does that become? It becomes a what? It becomes an I. And now, so I took care of that negative, didn't I? But now I got to take the square root of 36, which is 6. It's just as easy as that. Piece of cake, isn't it? Let's do another one like this, and then we'll move on. What if I said the negative? You can just do that in your head with hardly thinking now, right? So what's that going to be? 7I, just like that. And that's how quick you should look at it and be able to figure it out. It's not beyond your ability, is it? Not at all. What if we had something like this, though? What if we had like that? Because I can't take the square root of 13 and come out with a nice even number like I did here, here, and here. Well, if I broke it down, it's prime, right? So it's only 13 times 1, right? So I can't really break it down anymore, but I can do something with that negative. That negative inside the square root becomes what? An I. But I can't do anything with square root of 13, so what do I keep it? No calculator. I'm not going to put it into a calculator. We just put it under, we just keep it the square root of 13. See, we didn't take the 13 out of the square root, did we? It still stays inside the square root. We just took that negative and we turned it into an I. That still is the square root of 13. Now, this is where, in the book, they probably wouldn't put I5. They'd probably put 5I. They'd probably put 7I and 6I. In the book, though, sometimes, many times, instead of writing it square root of 13I, guess how they're going to write it? I square root of 13. Now, why would they do that?
To avoid confusion of people thinking the I is under the square root.
You got it. It's exactly right. Okay, she said it perfectly. Look, to avoid the confusion of people thinking that the I is under the square root. Because look, what if you're a little bit sloppy with that square root and made it extend over a little bit? That would be different. Okay, the I inside of a square root is not the same as the I outside the square root. So to avoid that, they put the I out in front. Okay? Would it be wrong to write it like this? No, not at all. All right? In fact, I usually end up writing it like this. But if you look in the book and look at the answers, they usually write it like this. We okay with that? It's not too bad, is it? Let's do a little bit more with that. What if I had this? What if I had like 6 plus the square root of negative 9? What if I did that? What do you think we're going to do here? I'm not going to go 6 plus 9, am I? I'm not going to go 6 minus 9. What do you think I have to simplify first? That's square root of negative 9. I got to simplify that first, don't I? This is just a regular whole number. I'm just going to put that as a 6 and put this as a plus. Now, we should be able to do this in our head. We did this a little earlier. What is that, Isaiah? It's 3i, right. Okay, it's 3i. Now, look at this right here, what I have. Do I go 6 plus 3 is 9? Why not? They're not like terms, right? They're not common terms. They're not like terms, okay? This has an I multiplied by it. This doesn't. I cannot add these together. So I would just leave it just like that. That's how I would leave it. Now, I'm going somewhere with this, all right? This right here doesn't have an I with it. Okay, that's a real number. Okay, all the numbers that we've dealt with up to this point, up to doing I's, have always been real numbers. But this right here, okay, is basically an imaginary number. Okay, or it's, yeah, we'll say it's an imaginary number. Okay, so that's an imaginary number. When I combine the two together like this, when I have a real plus an imaginary, we call this thing, guess what? What was the other word that I said earlier? The complex. We call that thing a complex number. Not because it's real hard, but you remember in English class you had like complex sentences, compound sentences, and simple sentences and all that? Well, a complex sentence, if I remember, was what? Like a combination of a compound and a simple or something like that, wasn't it? It was just a combination of two different types of sentences. Would you agree? That was a complex. Well, a complex number is just a combination of two different types of numbers, not sentences, but numbers. We have a real part and we have an imaginary part. Notice, which one went first here? The real. Okay, so this is what they do a lot of times. They'll write it like this. They'll write A plus BI. Okay, that's the real, that's the imaginary. This is the form that you want to write every complex number. Don't put the I first. Okay, the imaginary doesn't go first. It goes real plus or minus. It could be a minus in there, but real plus the imaginary. Everybody got that? So when you write your answers, when you have to add things together like we did right here, all right, or simplify them like this, the real always goes first, the imaginary always goes second. Remember this, A plus BI. That's your form for a complex number. You okay with that? All right. Let's do a little bit more. All right, let's do this. 9 minus 5i plus 4 plus 6i. Okay? And it says, perform the indicated operations, write the result in standard form. This right here is what they mean by standard form. Standard form. Okay? That A plus BI. So we want to add these things together, simplify it, make sure the answer is in standard form. Well, if you take a look at this parentheses plus this parentheses. In this situation, do our parentheses even matter? No, because nothing's being distributed, right? Nothing's being subtracted. I don't have to distribute a negative. So to tell you the truth, do I really even need these parentheses? Not in this situation, I don't know. So it makes it easy, just get rid of them. All right, it's not multiplication, is it? Because you had a plus in between. So you're not distributing, you're not doing FOIL method, it's just plain addition. Look, this is just as easy as a pre-algebra or algebra 1 class where you just had to add like terms. It's just as easy as that, even though we have i's here. Watch. What do we add first? What goes first in standard form? The real numbers. So which one are the real numbers? 9 and 4. Good. So 9 plus 4 is 13. So I'm done with those. Let's add the imaginary numbers together. And you add them just like it was a variable. Now remember, i's not a variable, is it? It actually specifically stands for a particular number, square root of negative 1. But we just add them like they're... Okay, negative 5i plus 6i is... Which one? Plus or minus? Negative 5 plus 6. Okay, the bigger number is positive, right? So it's plus. Plus what? 1i, or just I. You don't need the 1 there. If you put the 1 there, it's not wrong. You just don't need it. Is that in standard form? Is the real first, imaginary second? Yep. See how easy that is? See, so why the groan about imaginary numbers? No reason, right? There's no reason to groan about it because it's pretty easy stuff, isn't it? All right.
If they're imaginary?
Yeah, because, yeah, they don't even exist. They're imaginary. Okay. Let's do this. Let's do another one. We got a minute here, maybe. I think they're going to dismiss us pretty soon, but let's do this problem before they dismiss us, okay? Negative 5 over square root of 3. All right, let's do this. Now look, be careful with this. Don't just go negative times negative is positive. You can't do that. We work them individually. Now there are rules for this, but I'm not even going to go over those rules. I'm just going to work them individually. So let's do this square root of negative 15. Now, you know you got a negative in there, so you're going to get a I, aren't you? All right. What about the square root of 15? Can you break that down? I mean, it's 3 times 5, but you can't take 3 and get a square root out of it. You can't take 5 and get a square root out of it. So it's just what? Yeah. And we're going to write it I squared root of 15. That actually takes a little bit. It's a little rough for me to do that because I've always written square root of 15i, but the book usually does it like this, so let's kind of do it like that. Now, this is being multiplied, isn't it? Being multiplied by what? square root of negative 5. So how would I write that? That would be the square root of 5, what? I. Everybody with me on that? Over square root of 3. Now here's let me do this. Let me do this real quick, Tiff, because we're running out of time. Watch this. I got to multiply the I times the I. Let's do that first, okay? But let's think about what I times I is actually equal to. I'm doing this kind of off to the side. Now what is I? It's a square root of negative 1, isn't it? And this is a square root of negative 1. Really, what is it? It's a number being multiplied by itself. So isn't that the same thing as the square root of negative 1 squared?
Your
Look what
attention,
happened.
please. Students
The
are now
square,
dismissed to go to the Pusey
just
Center
hang on,
for chapel.
don't leave yet.
Students are now dismissed to go to the Pusey Center for chapel.
You got time. Watch this. This squared, what does that squared do to that square root right there? Cancels each other out. So what are we left with? It's negative 1. So what's I times I? It's negative 1. Or watch this. What is I squared? It's negative 1. That's important too. It's so important I'm going to put it in a box. I only put important stuff in a box, okay? So let's go back to this. We're not done. Come on. You got time, okay? You got plenty of time. All right? Nobody's going to mark you late because hallways are going to be crowded. You'll have time. Watch. So what's I times I? This I times this I. It's negative 1, isn't it? Okay? Square root of 15. Let's do this. Square root of 15 is the square root of 3 times the square root of 5, isn't it? Times another square root of 5. Square root of 5 times square root of 5 is 5. What? Square root of 3. And this is over what? Well, this is part of the problem, right? So look, this cancels, right, because it's being multiplied. 5 times negative 1 is negative 5, and bang, there you go. So we take a lot of rules that we had learned before. Let me give you a worksheet. Don't go anywhere. All right, and there you go. So you should be able to do this worksheet. We've covered pretty much everything on here.